The topic of discussion today will be load and store instruction encoding. Before we get into how to complete the instruction coding, we should first discuss what load and store actually is. With load and store, there's always a letter after the L and the S respectively. So if there's a B at the end, it means to load byte or store byte. In the case of load, there can either be signed or unsigned. And so for load byte, you can have LBU, which is load byte unsigned. Store does not have these, which is why you will see on this slide, there's never any SBU or SHU. So we have LHSH, which is load half word and store half word, and then LHU, which is load half word unsigned, and then LW and SW for load word and store word. So when it comes to what these suffixes actually mean, it really just determines how many bytes are going to be there and whether you're going to use signed or unsigned. So for the first example to illustrate load, we're going to cover load byte unsigned because that is usually where people have the most trouble because they forget that you have to indicate that is unsigned when you're doing your instruction coding. For the purpose of this example, I did not write out step 1 and step 2 because as we know, those steps are the same for all instructions regardless. So starting at step number 3, you are going to want to find the address. So because you are loading something, you have to find the memory address with which it is stored. And so that is why we do this step first. So first you load A and B. And so when you get to step number 2 in step 3, S2 and then B, you have to use a signed because it is always signed. And then you add S1 and S2 and push them to the destination. And then that is when we finally get to the memory address. And then once we find that, we're going to read the memory because obviously we want to load whatever that value is. So we must read the memory from where the address is. And so that is why we have our substeps 1, 2, and 3, which essentially grab the memory from that address or grab the data from that address and then pull it. So these brackets right here, that is getting the actual value of what is at that address. And so as you can see here, we have mem size byte because we have to indicate that we are doing LB and not LH or LW. So now we are moving on to step 5. So with step 5, this is essentially just moving it to a variable, moving that value that was at that memory address into a variable. And so when we come here to substep 1, you can see that this is a TXT. And so this indicates that it is a byte unsigned. So whenever we are doing unsigned, we use Z as opposed to S. And we do 8 because this is a byte. Moving on, we pass it to C, which is our variable, and we load that value into the variable. And then we save our final results into the register. Moving on to store. Store follows the same, almost the same principles as load does. However, only has less steps than load. So step 3 is going to be the same for load and for store. You are essentially finding the address because as was previously mentioned, when you are loading or storing something, you must go to the address where that value is at that you want to extract, either to load, or you want to push, which is to store. So moving down to step number 4, this is essentially the same as what can be seen in the load instructions. However, it is a bit different. And so you're just passing what's in your second, and you're trying to get that from the memory. And so moving on to step 5. Step 5 is where the instruction encoding ends, and that is essentially just writing the data to the memory as we want to store it there. And so you're going to go to the memory address and get that, and then push that to, or we're going to go to the address and get the value, or like get the data, and then we're going to push that into the memory, which is why down here we have this. And as we can see right here, once again, we have to declare the mem size and use that as our controls. And we designate it as half word because this is SH.